We're going to talk about compound inequalities. There are two types of compound inequalities, and they mean very different things. The two types of compound inequalities are or inequalities and inequalities. An or inequality is missing a couple of words. When we write x is less than or equal to 3 or x is greater than 12, we are skipping a couple of words. What we really want to say is x could be less than 3 or equal to, less than or equal to 3, or x could be greater than 12. So that could be is an important piece of our sentence. And if we think about some numbers that x could be that are either less than 3 or greater than 12, well, it could be 3, 2, 1, 0, etc. And we show that by putting an arrow pointing in the direction of where all those numbers are. Or it could be numbers bigger than 12. Now, it can't be exactly 12, but it could be like 12.01. Anything really close to 12, but not exactly, or bigger. And when we think or inequalities, we usually think of a graph that looks like this. All the numbers bigger than one thing or less than something smaller than it. Anything underneath either of these regions, here or here, is part of the solution to that compound inequality. Similarly, we're missing a couple of words from an and inequality. What we really want to say here when we read x is greater than 23 and x is less than or equal to 165, what we really want to say is x has to be greater than 23 and x has to also be less than 165. The difference between could be and has to be is very important. So some numbers that are bigger than 23 are 23, 24, 25, etc., etc. Now, 200 is bigger than 23, but according to our and inequality, x has to also be less than 165, which is why we can go up to 165, but not any bigger. I did make a small mistake here. I shouldn't have said 23. I should have said 23.1 or 23.01. A little bigger than 23, up until everything including exactly 165. By the way, there's a fancy word for this. The or is called the union, and the symbol for a union is that. And the and is called the intersection, and its symbol is the upside down of the symbol for the union. It looks kind of like a lowercase n, which helps because it goes along with the and the other symbol looks like an uppercase U, which makes sense because it's the union. There are exceptions to this, however. Actually, let me back up for 1 second. When we talk about the and inequality, this is what the finished product would look like. But a lot of times we think of it in two steps. We kind of do something else before we get to the finished product, and we say everything bigger than 23 is this. Everything less than or equal to 165 would be all of these numbers here, going on forever. And the solution to the and means everything in the overlap, the part that's covered by both statements. So that would be everything in here. That's the overlap. When we do this, it's better if we don't include these arrows, because we don't want to mislead people who look at our work and think that we're saying that x could be less than 23. But sometimes we do need to make more complicated graphs based on those arrows, so sometimes we'll have them there. This is what you think of when you hear and or. The and is this one with the overlap, and the or is the one where the arrows point the other direction, but it doesn't have to be that way. There are some exceptions. Sometimes it gets a little bit strange. For example, or inequalities might have no gaps. That's fine. If I look at this, x is anything bigger than negative 15, x could be bigger than negative 15, or x could also be less than anything less than 4. And because x could be either one of those two things, and every single number on this number line is either bigger than negative 15 or less than 4, that means the solution is all real numbers. And that would be exactly what you write down, all real numbers. We'll talk later on in the year what we mean when we say real numbers. There is, by the way, a symbol for all real numbers. It looks like an R, but with an extra backbone. You could also have an and inequality that doesn't look like normal. An and inequality might not even have an overlap at all. X has to be less than 5, and at the same time, x has to be greater than or equal to 12. Well, there are no numbers that are both less than 5 and greater than or equal to 12, which means there is no solution. And this will happen sometimes. Also, another exception you might see is that you might have a compound inequality that has arrows pointing in the same direction, which is different from the examples we've seen so far. So if we look at these two examples here, x is, or 3 minus 2x is greater than 9, and 4x is less than 16. Unlike some of the other examples here, this one needs a little bit of work. We need to actually solve this inequality. The good news is the rules for solving inequalities are the same for solving equations. As long as you do the same thing to both sides of the inequality, you're fine. Except when you divide both sides by a negative number, you have to flip the inequality symbol around. For this one, we'll just divide both sides by 4. So our final solution ends up being x is greater than negative 3, and I said the words flip the inequality symbol around, and then I didn't do it. You have to flip the inequality symbol around. So we get x is less than negative 3, and x at the same time is less than 4. Remember, has to be less than negative 3, has to be greater than 4, which is kind of a weird statement. Let's see what that looks like. X has to be less than negative 3, but at the same time, it also has to be less than 4. Our arrow is pointing in the same direction. Well, remember, and is the overlap, so what we're looking at are all of the numbers down here. So in my final answer, it would be a little bit weird if I include the and x is less than 4, because to summarize this yellow highlighted section, the overlap between the two, remember that's an open circle there, all I would really need to say is that x is less than negative 3. And that's my final answer. So please make sure you've looked at that number line, looked at the graph to see what the actual final answer is. Don't just put a circle around that and call it a day. On the other hand, if we had an or, notice how it's the same inequalities. I just flipped the word and switched the word around. So now when we were finished doing our work, it would be x is less than negative 3 or x is less than 4. And in this case, when you have an or, I'm saying x could be anything less than negative 3 or less than 4, which means it doesn't have to be both less than negative 3 and less than 4. So the numbers in between, negative 2, negative 1, 0, etc., they're part of the solution too this time. So because this was an or inequality, I really don't have to pay any attention to that negative 3. It doesn't matter to me. If a number is less than negative 3, well, it's already less than 4, so it would already satisfy that equation, that inequality.